I want to provide a little bit of clarification for this discussion board. Your x-axis should not be measuring time. That would be a time series graph. So this graph could be showing the amount of free time someone has during a week. They have about the same amount of free time during the week, and then their free time spikes on the weekend. That's not what we're looking for. That's showing how a variable is changing over time. And so if this is any measurement of time, here I have days of the week. Maybe you could replace that with the years of your college career. That's still measuring time. And maybe this is your grades then. So your grades are C's during the beginning of your career, and then you started doing well at the end of your career. That's again a measurement of how a variable, in this time your grades, how it's changing over time. That's not what we're looking for. The x-axis needs to be measuring the different values that your variable could possibly take on. So for this example, let's say it's the amount of time someone spends on social media each week. They could spend 0 hours, they could spend 100 hours. The x-axis would measure all those different values that the different amounts of time that someone could spend on social media. So it looks like for this person, they're spending 7 hours on average every single week. Some weeks they spend a little more, some they spend a little less, so looks pretty normally distributed. You could say it's maybe skewed a little bit to the right. It looks like there are some weeks where they spend a lot more time on social media than they typically do. Maybe it's weeks where they don't have to go into work that week. Or it's just a weekend they have no plans, so they spend more time. Let's look at another example. This one's even more normal. This could be the amount of time someone spends sleeping each night. And maybe if you're really, really consistent with your sleep schedule, you would have a normal distribution for the amount of hours you spend sleeping. So again, your x-axis needs to be the different values that random variable could take on. So anywhere from 0 hours spent sleeping up to, I guess, 24 hours if you slept the entire day, which I hope nobody sleeps for 24 hours straight. But if you're a very, very consistent sleeper, you would have a normal distribution for your sleep chart, where whatever amount of time it is you normally sleep, that's your average, that's what you normally do, and very rarely you're a little bit more or you're a little bit less. Now I know for me personally, my graph would definitely be skewed to the left. I hardly ever get to sleep in. But there are days where, for whatever reason, I'm only getting 4 hours of sleep or 3 hours of sleep. And so I have this little skew to the left because I don't consistently get to sleep the exact amount that I want every single day. Now let's talk about one final example. This example is showing someone's time it takes them to run a mile. So that could be anything from a low number, if they're super quick, maybe 4 minutes, all the way up to 30, 40 minutes if they're taking a really long time. It looks like this person, when they go out and run a mile, they're getting anything from a 9-minute mile to a 14-minute mile. So they're probably not a consistent runner who gets better and better over time, more and more in shape, and kind of gets that consistent time they can run every day. This person maybe is just sporadically going out and running throughout the year, and they've kept track of how long it takes them. Some days they're feeling better, I guess. They're feeling quicker. They run that 9-minute mile. Some days they're feeling a little more sluggish. They run a 14-minute mile. But for them, it's uniform. Their measurements over the course of the year were pretty evenly spread out among all the different times. They didn't really have one time that stood out more than the other. So you can have a uniform distribution if the variable that you're measuring consistently is the same across all the different values that it could take on. So for this discussion board, just pick anything in your life that you measure, that you get an actual value back for. It could be like one of these examples, how long it takes you to run a mile, or how much sleep you get each night, how much time you spend on social media or Facebook, how long it takes you to commute to work, how many calories you eat each day, anything you can measure. And then the x-axis would be all the different values that measurement could take place, and talk about how you think, for you personally, your data would be distributed among those values. Is it spread the same over a bunch of different values? Is it uniform? Is it like a normal distribution where there's one value that it takes on pretty consistently, the mean, and then all the rest of your values cluster around that mean with some a little bit less, some a little bit more? Or likely most of us don't have a perfect normal distribution for anything. Some of us do, but often there's a little skew either to the left or to the right where for whatever reason one tail of the graph tends to have more values than the other.